desde Tecnología.
Buenos días. I'm sorry, that's the extent of my Spanish for now. It's easy for me to present in English, so I apologize for that. I'm happy to be in Guadalajara. It's my very first visit here. The hospitality has been wonderful. You're wonderful people, so thank you very much. I want to relate to a few people in the room. I was glad that Brenda showed an example of coming from Sydney, Australia. I've been living in the United States for the last 20 years, but I'm originally from Australia, so I've taken a long journey to be here. Just 2 weeks ago, I was in Paris, France, and I was observing the reconstruction of the Notre Dame Cathedral there. And I saw the example of a model from Barcelona, the Familia Cathedral. And without the 3D model, the Notre Dame reconstruction would be very difficult. So they're now undertaking a long process to reconstruct that, and that was all done through some field technology called 3D scanning to create that original 3D model. So they now have that as a reference to bring that to life again. So what I'm going to present to you is some relationship to BIM and also what happens out in the field. Let me see your advance. So one of the problems is we've seen lots of presentations this morning about creating BIM models, creating the BIM process. And I come from an area, my background is in surveying and working on construction sites. So I've been working on construction sites and on major projects for more than 30 years, which puts me in the category that Fernando mentioned of the baby boomer. But I'm also a BIM baby. I've been involved in BIM since its conception. And one of the disconnects that has been is lots of theory about BIM, creating lots of detailed models, but that is lost in the field. And I want to show you some technologies that's going to connect the two together so that great execution happens. Moises showed an example of lots of pre-construction pieces. Those pre-construction pieces cannot be executed unless you have technology that allows you to position very precisely in the field. So what I'm going to show you to answer this connection between the field and the office with BIM is some technologies. One is layout technologies, which basically puts BIM in your hands. You take a field tablet, connect to some positioning technology, and follow the process to execute the design intent. 3D scanning technologies, I use an example with the Notre Dame Cathedral, but I'm going to show you now how scanning and BIM are in your hands in the field. I think that lots of people know about virtual reality today. They may have played some games, you may have seen it on your phone. I'm going to show you how you can use that technology to visualize and execute with BIM models in the field. And also mixed reality as well, where you can totally immerse yourself in the 3D data and how that can be used on a job site as well. So the first one is construction layout technology. So why is that important? Well, some of the key components of BIM is, one, the need for accuracy. If you have lots of pre-constructed pieces or you want to execute to the design intent in the field, then you need to have highly accurate technologies. The old ways of doing things, yes, get things done, but it comes with lots of setbacks on the execution not being correct and also not being done in a productive way. Also, what happens is once you take this beautifully visualized 3D model, what happens going from that 3D model into the field, it's printed out on 2D plans. So then it becomes a little bit more difficult to interpret from that 2D plan to constructing into 3 dimensions. One thing that this field technology, like layout technology does, it also provides lots of feedback from the field. In the background, in the field software with this technology, is gathering data. Data on, is it being set out to the exact location? Is it, how long is it taking? What piece is being constructed? All that information is being recorded, and that information then can be shared back to the office to give a sequencing of what's happening and is it being executed accurately. So this digital technology allows you to take existing technology that surveyors have used for many years, robotic total stations and GNSS positioning devices using satellites to position yourself accurately on the job site. We've adopted this for the use of contractors in the field. In fact, we had recently a MEP contractor that had a day's worth of training on our technology, and on that project executed laying out 20,000 precise points on that job site. So you can see that a contractor can take this technology with little training and be able to execute. And he told me that he was able to save the minimum of about 30% of his time in executing that job. So that reduces errors, creates efficiencies. One thing this technology can also do is also do quality control on the job site. So as things are constructed, you get precise positioning and you get data from that, that data point being captured, executed, and labeled on the model as well. So how does that start? We take the digital information and put it into a field controller and into a field software. Now, when I say digital information, you can have in the field a very complex three-dimensional model. The layers can be controlled. You can turn off the data on and off. So if you're one day doing the foundation of the building, you just show the foundation layer. The next day, if you're doing the mechanics of the building, you can turn that layer on depending on which contractor you are. One of the issues is that a lot of contractors don't have access to digital technology. Many smaller contractors are given paper plans and they don't have any way of digitizing that into the controller to be able to have it automated as far as that digital record is concerned. So what they can do is actually take the paper plan and we allow them to enter in digitally on the screen that information. So now they start to build what might be a very simple layer, but it starts to become a layer in the BIM model as well, even though they started out as a paper replication of it. We can take also 2D and 3D and layer that together. You see on the screen there, on the right-hand side for you, no, on the left-hand side, sorry. There are 4 different types of data sets in that model, which is actually running on a tablet in the field. There's an IFC model coming from Tekla. There's a DWG model coming from Autodesk. There's also a digital PDF, which came from a 2D data source. And there's also a SKP, which is a SketchUp file coming from SketchUp as well. Excuse me. So in the same project, we have 4 different data sources all combined into one job. And you can turn each layer off and on to visualize things differently. So we take that digital information on a controller, we connect to various devices. I talked about robotic total stations and GNSS receivers, but also there's specific tools that we've built for contractors where they don't have to have any knowledge of that technology as well. So what happens is I select the different data points or different elements in the model, and the instrument will guide me to the precise position. Now that can be done with a guided stick or pole with a receiver on it, or it can be a prism where I'm guiding to the location, or it can be simple as the robotic total station pointing to an exact location as well. So if you're laying out hangers in the ceiling, you can just point a laser up to that, mark it, and then drill your hole. And you can do that in a very quick time. There's also specialized applications built to do as-builting on the job site as well. So here's an example. Here we're measuring a surface. So if I've poured the concrete, I want to know the flatness of the floor. I can ask the robotic total station to automatically measure that surface. It will then compare it to the design, and it will give me contours that show me the high and low areas. I can then ask the laser pointer to point to that location. I can mark it out. So I can mark, it will also then calculate volumes for me. So I know if I have to do some self-leveling concrete to pour in an area that is low, I know how much volume, so I can give that information to that contractor. All this data is recorded, and I can provide it in a report that can simply be sent back to the office as a representation as well. As I mentioned before, as all these tasks are being carried out, there's lots of reporting done in the background. So here's some examples of measuring each data point. It's giving me the exact coordinate and also the variation of where that was executed on the job site. It's also measuring different parameters of what is being taken place. So it marks the time of every single element that's being laid out. It tells me how long it took for that person or the crew to lay it out. Now, the significance of that is not just to track the productivity of the people doing the job, but it allows us to know if I do a similar job in the future, how long is that process going to take? So that helps me both from an estimation point of view, but also from a scheduling point of view as well. On the right-hand side, what you see is a field report. So this technology, whether it be the tablet or the instrument itself, has cameras in them. So what I can do is I can, if I see an issue, I can take a photo, you can measure the exact coordinate, and I can send that directly from my controller back to the office, whether it's in an email or synced up through some sort of server as well. So I can get direct feedback from the field about an issue that's happening in the field, and then I can mark and set a task for somebody to go out and inspect it and make a decision on what is going to happen. So what happens with some of this data? So I'm out in the field, these things are being laid out in the exact location, they're starting to become constructed. What I can do is I can feed that back into my authoring CAD software. So in this example, you see, if I use a laser pointer, these areas that are clouded out is the point data coming back to the original BIM model, and the marked out area here is showing where there's a deviation from the original design intent. So then I have to make a decision. Is that variation going to affect the future construction of what's going on? Do I need to move something to fit in with what's being constructed? Or is it a situation where I need to actually change something? So do I need to submit a change order to get it corrected? Also, what we can do is take a shared BIM model out into the field, and I can update the status of the construction process. So here's an example where you have a shared model that you log in through your controller, log in to the shared model, download the current version. It will then mark in a color the status of where that was yesterday, for instance. What I can do then in the field is, as I see things being constructed, I can mark them as being in the process, or not completed yet, or completed. So you see that in the different colors there. The green is obviously a completed element. What I can do then is, then I sync up via connection through the internet back to the shared model. It will sync up then the latest status. So the people in the office then will then review this same model, and they can see the current progress of what's actually happening out in the field. So this is in near real time as it is happening, and you're getting exact data of the execution from the field. So this is what I would call field to office BIM in real time and in a real situation, not theoretical. So this information then helps us for a better coordination of the project, which is actually the intent of the BIM process, and also helps us with future estimates so that we can also develop either a better process or a better project for the next time. So another technology that can be used for execution of BIM is 3D scanning. So why 3D scanning? Well, with the demand of more complex models, you need more complex information. So if you have an existing structure that you don't have any information about, you can use 3D scanning to capture that information. It captures a high fidelity of millions of data points. You saw some examples in previous presentations. So we can then do that for the pre-planning of the project. But also, 3D scanning can be used during the process of construction. We can do tracking of progress, and we can actually create deliverables, and we can also do construction verification with 3D scanning technology today. Now, I was involved in 3D scanning technology. I worked for a French company called Mency that was later on purchased by Trimble. And at that time, we had 3D scanning technology that we released, and that measured at 70 points per second. It was an instrument that was looked like a torpedo. It was very large. It cost around about almost $200,000 at the time. And it was used for specialty applications. Now we have today technology that is, in the same realms of a robotic total station for price. You're capturing millions of points per second to capture a lot of information. And the problem in the past is that information had to be captured, taken back to the office, processed, modeled, and then compared. Today, what we can do with this new technology is we actually do all of that in the field. So with this new technology, what we can do is we can capture the data, we can geo-reference it to the model, and we can see the point cloud as we progress around the job site. It's actually automatically stitching itself together, and it's also referencing itself to the model. So also built into this technology is some basic layout capability as well. Has a laser pointer built in. And we can verify certain locations. Also, what we can do directly from the field tablet, we can create a view and we can export directly into your CAD authoring software as well to be able to see that comparison back in the office as well. So what does that look like? So here's some examples. The red here is the point cloud. The blue is the 3D model, and you can see the point cloud and the model together in real time in the field. You can also have any of your specific layout points as well. Down the bottom here, you can see here the ducting. The green is the model, and this gray representation is the point cloud. So what you can do is you can actually take, not only visually compare, but you can take measurements between the point cloud and the model. So then we can make a decision, we can make a decision on, is this fitting correctly? Is this where we want to execute? Or is this something that we need to reference to somebody to make a redesign? All this is happening live in the field. So as I mentioned before, you can create a 3D view of the area that is of particular interest. And then we can export that in a CAD format so that you can send that back to the office and that they can start on doing some comparisons or maybe doing some redesign. So very exciting transformation of using this technology from what was, say, 18 years ago, where you captured data in the field, and 3 weeks later you actually had a model, and then you could actually do something with it. Today we can do live in the field. So a great transformation of adopting a technology to now becoming what I call BIM enabled in the field. So also with this technology, you can, it has basic layout capability. So what we can do is take the comparison of the information and we can ask the laser pointer to point those to those locations. So a good example of, as I mentioned before, using the robotic total station to measure your surface and to find the high and low areas. In this case, you could use the 3D laser scanners to do a very similar task. So here you can see the laser pointer on the concrete surface. So how about some newer technologies and how are they being used on the job site to help execute the BIM process? So we've invested a lot of effort in creating dynamic 3D models with lots of information. And as I mentioned before, some of that gets lost because we take it and put it into 2D plans on a job site. And I spend lots of times on job sites. I've worked on lots of job sites. And primarily what are people using in the field is 2D information on plans. So we're trying to change that with tablet technology connecting to positioning devices. So other devices can also help you visualize this data in 3D and have access to the BIM layers of information as well. So one of those is augmented reality. So what we can do is take a normal phone, write an application to it, and we can connect it also with precise satellite positioning. So this product allows you a digital window into the job site. So you have your phone, you have your precise positioning, and it'll actually position you exactly where you are on the job site. So what we can do is even take complex 2D data and overlay that into the real world as well. So you see this complex information on an intersection. You see the 2D plan of where the information comes from in the digital format, and this has been projected into the real world through this digital window. Here you can take the 3D model, actually see what's actually under the ground that was designed or actually executed in the past. You can tap on the element of the model and see all the BIM attributes that come from that information. So this information is available to you in your hands, and you're at the exact location. You're not trying to find and interpret where you are within that model. A good thing is, although it's using satellite positioning, it's also using the positioning capability of the phone as well. So in very small spaces, the GNSS can be turned off because inside you can't read satellites, and you use the tracking technology that's inside the phone to map your surface, and then you can place the model in that perspective as well. And then the great thing about this in the model, we can, on the job site, even if things aren't even constructed, we can view it from different perspectives. So we can be outside the building, we can walk around the building, we can be inside the building looking out, seeing what that's going to look like. And that helps us, even before construction, to help make decisions. Is this really going to work? Is this going to suit the client that's having this constructed? Maybe they want to make some changes by just viewing this on the actual job site. It's very difficult for a customer to say, I want to build this multi-story building, but what's it going to look like from the 10th floor? You can actually take that person to the 10th floor in a virtual world so they can actually see what it might look like. And that helps them with selling out or leasing out that space, for instance. One of the things we can do with this technology, we can do construction inspection during the process. So now you see on the screen through your digital window, you see what is under construction, and then you can see what hasn't been constructed. So then you can actually know where we are in the schedule. Is it being executed correctly? We can look even at pieces that have been put underground. We can record the locations. So what we can do is, with the GNSS receiver, we can actually take a position and record it, because this area is going to be covered up later on. We don't know where that is, so we can actually record it for later. And then also, that product I showed on the first slide of augmented reality also has electronic distance measure in it. It measures only about 15 meters. But you can actually go out there, measure the location, even if I can't get to it, and can record that location. I can add information, add layers of data to here, not only the position data, but add details about what I'm seeing. Importantly, also, I can assign and create tasks from the application on the phone as well. So at that location, I can create a view. And so you see on the right-hand side, a digital 3D view of the overlay of the 3D model. And also, it can take a picture. So I see in the background, the picture coming from the phone and the 3D model overlaid. So I have that image. And now I can assign a description, and I can assign a task related to that part of the model. So if I see an issue, I can maybe assign a task to the structural engineer to say, okay, we need to make a change here. I can then sync up and send that directly back to the office. So again, executing in the field and BIM connection from office to field in real time. So another technology that you might have, if you attended last year's conference, one of my colleagues presented mixed reality. Mixed reality has come a long way in that time frame. There's a new device out called the HoloLens 2. We've adopted that technology to create what we call the XR10, which takes the HoloLens 2 and places it on a safety helmet so we can use it on the job site. What does mixed reality do for me? It fully immerses me in the digital world and the real world at the same time. So when I'm walking around the job site, I can visualize the 3D model one-to-one in the space that I'm in. So even though the pieces don't exist, I can actually visualize them, see them. I can tap on them and see all the BIM layer information. I can then walk around the job site. As I walk around, it's mapping my location through the sensors that are available. So what I can do is, it gives me a great way to verify the design intent and how it's being executed on the job site. I can do, if I'm in a prefabricated environment, I can actually have the design model overlaid in my real space that I can then relate to and build my prefabricated pieces. I can use it for on-site installation, so I can actually see what I'm taking the pieces that I see in front of me and how am I going to put them, say, up in the ceiling, for an example. I can do QA, QC, and I can assign tasks, just like I showed you with the augmented reality. I can actually assign tasks from inside my headset, and I can assign them actually just by talking. I don't need to type things in. The voice recognition works very well, that I can actually speak to it, and it will speak me through the tasks as well. So some of the new technologies with the HoloLens 2 that allows me to do this in a better way. One, the performance is much faster than before. It has a lot more tracking technology, including tracking your eye movement. So when you're looking around the space, it knows what you're looking at, and it can automatically, you can talk to it. So you're talking to Cortina, because it's a Windows 10 based platform, and I can say to Cortina, okay, pipe element, reassign and redesign, and send that to David in the office. It also allows me, also when I put on the device, it can have the ability to log in without having to type with gestures, to scan your iris and log you immediately in, load up the model that you're interested in because it knows where I am, and then load that automatically into my space. Also in the past technology, you had to use some, what I would call unnatural gestures to interface with what you're seeing and the model, and now it has much better natural hand gesturing. So I can just point instead of tapping. I can grab and I can move. And you can try all this out. We have a device out here that if you want to experience this yourself, we have one of those devices available for you to try it out. So here's an example of using this technology in a prefabricated environment where you have people putting together rebar cages. They can see the design and they can actually tie it together, and they're working because they can see the real world and the model world at the same time. So not only for on-site, but also off-site where they're doing lots of prefabrication as well. So in conclusion, in connecting with lots of creation of BIM and the BIM processes, to execute in the field, even though lots of 2D data is still being used, but more and more 3D data, technology can be a driver to help us execute BIM in the field. Because this technology allows us to visualize things in a better way, in a more natural way. Because visualizing in 3D instead of taking a 2D plan, trying to visualize it into 3D, is great for people who have lots of experience in doing that. But to be able to execute in a better way and to avoid making mistakes and adding time frame to jobs, and to make sure that the design intent is really executed well, visualization is key. And then also a critical path, and I think it was mentioned before, the data flow from the office and to the field and back again is critical. And technology allows us to do that today. The internet is everywhere, not necessarily on every single job site, but lots of job sites. If it's not, then the data can be near real time. So as soon as you have some sort of connection, whether it be through your phone or a hotspot at some sort of cafe somewhere, you can get the data back to the office in a faster manner than actually having to drive it back there. So things have elevated, and technology is allowing us to execute BIM in the field. Thank you so much.